Welcome everyone to the Calendar Roll Challenge Project presentation by Isothermal Community College International Internship Team. I, Darius Fleming, along with members Arissa Bolin, Logan Striff, and Karsten Kimmick, will be presenting to you today our analysis of the calendar roll process. We recognize you all are the experts and we appreciate the opportunity to work on the calendar roll project. This is the trelleborg project review summary, and this is the isothermal calendar project. Roger is our project owner overseeing our project. Our project champions are Keaton and Matt. All of us were the team members. Our problem statement is there is no quantitative or data-driven determination for calendar roll grinds. This results in excessive grinding and or reactive grinding that leads to scrap. Roll grind 3 times per year, which costs about $30,000 per year. Average scrap a year is 62,718 yards gas meter product. Goal is to reduce at least 1 grind a year. We are analyzing the impact on gas meter product by monitoring and calculating production yards and cost of scrap. We started our project by creating a fishbone diagram of the 3-roll calendar. We brainstormed all the possible causes that gave us the problem. Then we categorized the problem by the 6 M's on our fishbone diagram, which is measurement, material, machine, mother nature, manpower, and method. All the M's lead to the problem, which is the calendar rolls are getting high-low spots, which cause product defects and result in material scraps and excessive maintenance of calendar rolls. Countermeasure is grinding rolls to prevent off quality, and we need to estimate when to grind rolls. It's quite expensive for the contractor to grind calendar rolls. Here's the cost and machine downtime. And now Arissa will show you the next part of our presentation. Thank you very much.
Thank you, Darius. Today we'll be talking about the 3 methods that we use to analyze when we need to schedule a roll grind. So today we'll be talking about time, production yards, and scrap. I will be talking first about it as a factor of time, which is our current method, and it's not incredibly precise, but it does have its advantages. We calculated about when a roll grind is scheduled, and it's approximately 4.3 months on the current method, and that is variable a lot right now because we end up scheduling earlier or later depending on what happens and how much product is run. So this is really just a general idea. This has some good things. It's predictable. We can schedule months in advance, even years, on about approximately when we will need a roll grind, and the contractor can be set up and ready to do that. The cons is that oftentimes it needs to be done much earlier than that, and we end up producing more scrap than we really should. Or we grind too early and we shorten the lifespan of our rolls. So currently, because of this, how predictable it is, we are able to predict that it will cost about $30,000 a year on roll grinds because we grind triannually, and we also know what dates will be most likely to be grinded on, such as July 2021, November 2021, and March 2022. We also use a second method that we found that you can use is roll grinding based on production yards. So be able to see, on average, how many production yards are needed before there are major problems. Using a calculation of a few months, we were able to find that approximately 300,000 yards are run between each and every roll grind of your specialized gas meter product. And here's a graph that we have created based on this data. This graph shows that there are defect yards in blue and the production yards in gray, and we have our average roll grinds in orange. This is an interesting graph because it shows us exactly how much the increase in scrap happens over time as we get closer to the roll grind, but also how certain months can be much worse than others and require more than just every 4.3 months grind. The pros and cons to this one is that it is predictable. We can see how much the supply chain is going to run through, and we know approximately when it's going to need to be done. The problem is that we found that it isn't extremely accurate, as it doesn't account for problems that may occur. The third and last thing is roll grind prediction as a factor of scrap. So we know that on average, how much scrap is produced each month. And we have calculated that here with the numbers on the screen. We predicted about how your average monthly is, and that gets us about 25% of what your total scrap is. But looking at your data, you have more scrap nearing the end of your roll grind period, almost in a bell curve shape. So it doesn't account perfectly the 25% at the beginning of the month. Thus, we've discovered that it's about closer to 15% of your total scrap is near the beginning of the month. And thus, we have discovered that it is not our original number of 25%, more of our 15, which is about 9,345. And because of this, and because of how predictable this method is, we found that we can predict into the future for your next couple months and find that there is a 31% improvement for this year, let alone just based on what is already being done to fix this problem. And that could be as much as $10,000 savings. The pros to this is that it is very precise, and it is also able to predict early enough that we can schedule an earlier roll grind. The cons to this problem is that it requires time and effort to get enough data in our system to get continual and correct predictions. The other problem is that it does cut back on the amount of time. We cannot predict 6 months in advance when a roll grind is going to be needed. It's more like 3 months, and that it can cause problems for when we need to schedule a contractor. And I will now hand this off to the conclusion to Karsten.
Thank you, Arissa. So in conclusion, we recommend to monitor for when around a time period of 4 months since the last roll grind has been done, or when around 300,000 yards have been produced, whichever happens kind of first. We then recommend to start monitoring the scrap more closely for when at around a 9,300-ish per month of scrap is being produced, to then check and see if there are high or low places along the rolls, which are the cause of this extra scrap. We also recommend that to run the production in longer runs rather than shorter periods over different times, as we realize that it produces more scrap doing shorter periods over and over. We also thank you for all the experiences we got to be in this project, such as a professional job interview, the safety and PPE training, a tour of the plant and seeing how a actual plant runs and works, as well as working closely with the machine. A big thank you for everyone who participated and helped us with this presentation, and especially everyone at Trelleborg, such as everyone listed. Now introducing Ann Hardy with the future goals of the project.
Thank you, Karsten, and thank you to all the students who have been involved with our international internship program. Here is a status update on our international internship program. We have now completed phase 1, which is our Trelleborg Roften project. Phase 2 is to actually travel to Trelleborg, Sweden, which is proposed for spring of 2022. Phase 3 is to recruit our second group of students, which is proposed for fall of 2021. Then we'll enter the Trelleborg plant once again and start a brand new project. Thank you for all of your time. Thank you very much.
The isothermal project team did a great job coming in, working with us, identifying solutions to our problem, and we're really impressed with the solutions that they came up with. We're actually planning to change our behavior immediately following their suggested solutions, so we couldn't be happier with the work that the project team did.